Hello everyone, I'm Prajwal and this is my friend Venkatesh. We are here to talk about Eeg controlled rover, a brain-computer interface.
Hey everyone. So a few months back, me and Prajwal were working on brain-computer interfaces, and we have built something which we thought would be interesting enough to present it on this talk. So we wrote an article on Medium, so that's what we are going to follow. Yeah, so what you're seeing on the screen is an Eeg device. What it is basically 5 electrodes hooked up to an amplifier, which is capable of monitoring your brain activity. When I say brain activity or neural activity, it is just the electric impulses that get produced in your scalp part of your head when you think of something, or almost all the time in your life. What we have done is that we have collected enough data from this device. What you're seeing on the screen is a waveform of those electric impulses that are generated in your brain when you're thinking something. So what we have done is that we have collected enough data from this EEG device and fed it to a deep learning model. Deep learning model which is capable of classifying sequential data. As the data is in a sequential format, the thought is never a discrete electric impulses. We needed a deep learning model which can be able to classify sequential vectors. So we fed enough data to this model that it was able to classify 4 different types of thoughts, like push, forward, backward, rotate left, rotate right. So once the model was intelligent enough to classify these 4 thoughts, we have decided to make a very cool application out of it, which Prajwal will explain. Thank you.
So yeah, a brain-computer interface. So as a fun little hack for this summer, we built it. So just to give you an idea of what the project does is, I am the test subject. I'm wearing the EG headset. I imagine the thought move forward and the rover moves forward. I don't have to push a button. I don't have to use an analog or voice commands. I just have to imagine it. So this is the system architecture. So here we see a subject wearing the headset. So when the subject imagines the thought move forward, the EEG headset reads this thought and it transfers it to the computer as a raw stream of vector data. And the model pre-processes this and then classifies the command as the move forward command. The Raspberry Pi of the rover receives it, and then it sends it to the rover, and then the rover correspondingly moves forward. So reiterate, I imagine move forward, reverse, rotate left or right, and the rover just does that. To show you working of this, yeah, let's go scroll up. So, yeah, so, sorry about this. So yeah, here's me sitting awkwardly in a corner trying to move a rover with my thoughts. I imagine move front, it moves front, then rotate left, it rotates left, and then again front. So yeah, this was the working of the model. We could not have done this without Python. Python was used from A to Z of this project, from pre-processing the messy data that we received from the headset, putting it into a vector form of 5, and then sending it to the model. And of course, the model, as anyone's guess, was also written in Python. It was an LSTM network, and in the end, the server which communicates between the headset and the rover's Raspberry Pi was also written in Flask. So yeah, I owe most of this project due to Python's help. Yeah, and if you guys want to read this, this is my post on Medium. I'm sorry I could not make a PowerPoint on time. You can read it. You can find it. My username is Prajwal Gatti, and yeah, this was co-developed by Venkatesh and I. Thank you.